This is going to be just a short lesson talking about the material of day 7 of your refrigeration course. This is core refrigeration. And I want to talk specifically about the assignment, the schematic of the day 7, your lab 7A, and then the two diagrams that go along with it. But we're going to start with the assignment of the day. So when we take a look at the assignment of the day, it's asking you to draw a ladder schematic of a shaded pole motor and a PSC motor with all components shown on the ladder diagram. The shaded pole motor runs constantly when the circuit is energized via a single pole breaker. That might be your service switch on your trainer board, by the way. The PSC motor cycles on and off based on a close on rise line voltage thermostat. It's a cooling thermostat. Okay, so what you are drawing here is a basic cooling circuit where the evaporator fan runs constantly and the PSC motor, which is your compressor, cycles on and off based on the thermostat. So what we're going to do is I'm going to switch over here to my whiteboard, okay, which hopefully you can all see. Okay, we're going to start off by what we do most often with any diagram. Okay, I'm going to start off with a line and a neutral. Let's go ahead and draw in my single pole breaker before we go too much further. We're just going to call it SS for service switch. Okay. I'm going to go ahead and draw my neutral line in too because we don't want to forget about that. Then I'm going to go ahead and the evaporator fan motor is a shaded pole motor that runs constantly. Okay, so let me just neaten that line up a little bit here. Went too far over there. Okay, so let's label this. I'm going to label it EFM for evaporator fan. Okay, now we have a PSC motor that is cycled based on a cooling thermostat. So let's draw in my cooling thermostat. And let's go ahead and draw my PSC motor. Remember, PSC motor has a run cap in it that is always in the circuit. So we have two windings. And we return to neutral. So if we label this, this is going to be my run, start, and let's just label the whole motor. Let's just label this CMP for compressor motor because that's probably what it's going to be. So again, when we look at this diagram, I have my service switch, which is my single pole breaker. I have an evaporator fan motor with a shaded pole, that's a shaded pole motor wired to run constantly. I have my PSC motor with my run cap in here, okay, and a thermostat, that's a cooling thermostat, and that cycles that motor. So that's that diagram, okay? So if I go back to my assignment of the day, okay, we've met that. Now, let's go ahead and take a quick look at the lab, okay? Now, the lab is having you measure the C, R, and S windings. Let's say you get a compressor that you have no clue what the windings are, or a motor that you know is a PSC motor or any split-phase motor and you don't know what it is. Okay, you're going to have 3 terminals on the side of the motor or 3 wires. To find the start, run, and common wire, you're going to take a reading across all 3 wires. Okay, A to B, A to C, and then B to C. The wire that is not included in the highest resistance, okay, is your common terminal. The wire that is part of your resistance, okay, the wire that becomes, hang on, the wire that is the highest resistance after that, okay, is your start winding, and then the one with the lower resistance from that to common is your run winding. Okay, and that's what it's walking you through the procedure here. Now, it's asking you a few questions. What could cause start, run, and common windings to burn out in a compressor? Well, there's a number of reasons. Okay, first is heat. Okay, heat is the biggest enemy of a compressor. Okay, then you have acid. Okay, that's caused by moisture in a system. Then you can actually have the bearings seize up and again start heating up and don't allow the compressor to cool. And then you might have like start components that are not working properly and stuff like that. But it all comes down to basically heat or acid, which is caused by moisture. And then you did a drawing of the different types. Then you probably did a drawing of the different terminals. Okay, so that is Lab 7A. But again, the core component of this lab was to make sure that you had the ability to do a measurement of start, run, and common. Okay, now let's go ahead and talk about the first diagram. Okay, the connect the dot diagram. So let's pull this up to, I'm going to say, let's pull this up to a full screen. Okay, and I'm going to pull this down a little bit so I can see the whole diagram on one page. Okay, so we have our diagram here. Okay, and let's go ahead and connect these first terminals. Okay, this is the one that's labeled motor 05. What you're looking at is you're looking at a PSC or a CSIR motor. Okay, because we have a start cap, we have a start component, and we do not have a run cap on this. So the way this works is we're coming in from line down to our thermostat. We're coming out of our thermostat to L. Then we come out of M. M is main, okay? In this case, there's nothing between M and the run winding of your motor. S is my start winding. However, we have a start capacitor, so let's come out of S. We're going to go to our start capacitor, and we're going to go to our motor. Now, we're going to come out of C, and that would come back to neutral. Okay, so this would be my neutral. This is my line. Okay, now, if I were to draw this out in a ladder diagram, okay, I'd have my line. I'd have my neutral. I'd come out of line, come across to a cooling thermostat, actually we'll do this on another screen because I'm running out of screen space there. So let's go ahead and go here, and I'm just going to quickly remove that. We'll clear all there. And then again, if I did that diagram that we just did, I'd have my line, my neutral, come out of line, cooling thermostat. I'd come to my motor run winding. I'd come out here to my normally open contact. I'd come out of that to a capacitor. Do my start winding. And then back to neutral. And I'd probably put a little dotted line around that. Label my components. TS for thermostat. Okay, SC, run, start, common. Okay, because everything inside the dotted lines is a single component. Okay, so that's that diagram. But again, basically what you're looking at in that diagram is you are looking at the compressor part or of a cooling circuit. I don't have the evaporator fan in here. Okay, so type of motor, okay, is a PSC. I can't tell you the motor resistance, okay? Oh, sorry. 6 is my run winding because it's the smallest, and 14 would be my start winding. So we also have 7C, okay? 7C is your complete refrigeration circuit, with the exception of the fact that the condenser fan here is going to be a PSC motor, but on your boards it is still a shaded pole. Okay, so let's go ahead and take a look at this one. Okay, so we're going to go ahead and do this one as well. Okay, so the first thing I'm going to do, remember, this is a alternating current, so it really doesn't matter whether or not L1 or L2 becomes the equivalent of connects to the common. So I'm going to go ahead and take L1 around here so I have a common connection on all my motors. Let's not forget about wiring in common. Okay, so I'm going to take L1 all the way around. My evaporator fan in a commercial system runs constantly. Okay, everything else is wired off the thermostat. So I'm going to come in here off my thermostat. I'm going to come down to L on my current coil relay. I'm going to connect in my run winding, which is the lower resistance. Actually, let's go ahead and do that in a slightly other way. So we're just going to erase that wire there. Let's make this a little bit neater. Okay. We're going to come to my run capacitor just as a junction point. Then I'm going to come down to my run winding. And then I'm going to put my run capacitor in series with my start winding. Now here, M we know goes to R, S goes to S. So what we have is we have a line 1, we have a double pole breaker controlling my evaporator fan, which runs constantly. My thermostat controls my PSC condenser fan motor, and my split phase, no start components, okay, compressor motor. This is a very frequent circuit you'll see in refrigeration. Now, if I wanted to do this same thing over on a ladder diagram, which you really need to be able to do, okay, we'll come over here, we'll erase the last one. Nice thing about a white. So in this case, what we want to do is we want to go ahead and draw my ladder diagram. Okay, so remember, we have a PSC motor, we have my evaporator fan motor, which is a shaded pole. I have my condenser fan and my compressor that's controlled off the thermostat. Well, let's do the easiest first, okay? So what we have, we might as well do my side rails on my ladder first, okay? So let's get that in first. So we have L1 and L2, okay? We have to, let's go ahead and put in, before I forget, let's go ahead and put in these circuit breakers. We're going to do one on each side. And again, sorry about the waviness of the ladder, but I'm drawing this on a mouse pad that I can't, that doesn't have the display like your iPads do. Okay, so we'll just connect the two of these with a dotted line to show that they function together. And we'll just call that SS and SS for service switch. Okay, now, evaporator fan runs constantly. Okay, so it's a single coil because it's a shaded pole. We'll label it EFM. Now, back to our other diagram. Everything else is off my thermostat. So what I'm going to do is let's go ahead and get that thermostat in. Okay, it's a cooling thermostat. Okay, we'll label it TS. Let's go ahead and do our condenser fan motor, which is a PSC motor. So we have a run cap with a run and a start winding, and that will come right back. Okay, let's go ahead and label that. Okay, and we'll give the whole thing a label just so we know what it is. CFM. Now, also out of there, we have my compressor. Okay, compressor, if you remember right, what we have is it's a split phase with no start components, but with a current coil relay. So let's go ahead and get that current coil relay in. Okay, we have a coil that goes to my run winding. Okay, my start winding is connected to a normally open contact. Okay, now that's going to be L, M, and S. And that's my run, common, and start. Let's go ahead and throw a little box around this guy. Okay, so that is basically the identical circuit you have here. Oh, let's label this compressor. And again, sorry about the wavy lines. The tablet I'm working on doesn't really let me see on it where my cursor is. So, okay, again, evaporator fan runs constantly. Thermostat controls my condenser fan and my compressor. The only difference about this circuit from what you're going to see on your training board in the shop is the fact that the condenser fan motors on your boards are shaded poles. So they will look very much like that evaporator fan. The rest of it is very accurate.